Hello everybody. Today we are going to discuss about sequential logic circuits. A sequential logic circuit is nothing but a combinational logic circuit with memory element, and it combinedly forms a sequential logic circuit. It consists of a combinational circuit to which memory elements are connected to form a feedback path. Now the memory elements that can be used are nothing but the flip-flops. These memory elements are devices which are capable of storing a binary information within it. This is a block diagram of sequential logic circuit. The sequential logic circuit consists of combinational logic circuit block. The input is there and output is there, while in a feedback path we have a storage element which is nothing but a memory element. Now this storage element is required to store the information of the output, because the sequential logic circuit is depending the output of sequential logic circuit depends on the input of that sequential logic circuit at that particular instant, plus the previous condition of output as well as the current condition of output also. So therefore this the sequential logic circuit needs that storage element which will stores the data or information that has happened in the past. And the basic unit for storing this information is nothing but a flip-flop. Now there are many types of flip-flops, or the flip-flops which are there in a digital circuits are basically of four types, and these four flip-flops are named as SR flip-flop or RS flip-flop, that is set reset flip-flop or reset set flip-flop, then JK flip-flop, D type flip-flop, that is delay flip-flop, and T type flip-flop, which is a trigger or toggle flip-flop. So these are the four basic types of flip-flop which are being used in different sequential circuits of digital electronics. Now let us discuss about one of the sequential circuit, which is nothing but a resistors. There are other sequential circuits also which can be considered as counters, then shift resistors. So here we have a resistors discussion. A resistor is a group of flip-flops. Each flip-flop is capable of storing 1-bit information. So obviously n-bit resistor consists of a group of n number of flip-flops which are storing n bits of binary information. In addition to the flip-flops, there may be a combinational gates or some basic gates present in this resistor circuit. The types of shift resistors are based on how the input is being taken and how the output is coming out from that particular circuit. So input is provided in two ways, either in serial manner or in parallel manner. Similarly, the output also can be taken in two ways, serially or parallelly. So based on these combinations, we have four different types of shift resistors. One is a serial in, serial out, that is SISO. Another is serial in, parallel out, that is SIPO. Then parallel in, serial out, that is PISO. And parallel in, parallel out, that is PIPO. So these are the four different types of shift resistors which are available in shift resistors type. Now shift resistors are used for different purposes in digital system. They can be used for temporary storage information in microcontrollers and microprocessors, then data manipulation and transferring, then counting circuits such as simple counters, variable modulo counters, up down counters, incremental counters, and so on. They are also used in different electronic circuits or different electronic systems to convert the data either from serial to parallel or parallel to serial format. This is a general use or general applications of resistor that we can found in digital circuits. And In case of conversion of data, these particular registers are operate or driven by a common clock signal. Now here this diagram represents the diagrammatic representation of shift registers. Here we have a serial input and serial output. So this is a SISO type of shift register. Here we have a serial input and the output is taken in parallel form. So SIPO type of register. Then here we have a parallel input of data and the output is taken as serial. So it is a PISO type of shift register. And here we have the parallel input and parallel output. So it is PIPO shift register. Now let us see the function of each and every shift register in detail for all the four types of shift registers. So first of all, let us discuss serial in, serial out shift register. Here in this diagram we can see the 4-bit serial in serial out, that is SISO type of shift register. The 4-bit because it consists of 4 flip-flops, that is FFA, FFB, FFC and FFD. They all are having a common clock pulse. Okay, moreover they can also have a clear and preset signals, which by the way of which we can directly give the command of clearing the flip-flops or resetting the flip-flops. In this register, the data is allowed to flow straight through the registers, directly, serially in and serially output. So there is only one input and only one output. So data enters and leaves the flip-flop or leaves the register in serial manner and serial pattern. Hence the name serial in, serial out shift register. Now the effect of each clock pulse is to shift the data contents of each stage one place to the right, and this particular thing can be seen in this particular truth table, where at 0th clock pulse the condition of all the flip-flops is 0 0 0 0, suppose. Now when one clock pulse will come or first clock pulse will come, let us consider that the data 1 is being present in flip-flop 1, so the output available is 1. Now that means the output of flip-flop A is QA and that is available here as 1. Now the second time when the second clock pulse will come, this data will get shifted towards right and it will be available now at QB, that is the output of B flip-flop. Then in the same manner, when the third clock pulse will arrive, the data will get shifted or data bit will get shifted to next flip-flop, that is the flip-flop number C, and therefore the output is available at QC1. Then the next clock pulse fourth, when the data of QC will get shifted to D. In this manner, in all the 4 clock pulses, the data bit 1 is being shifted to right and it will go to the end flip-flop. So this is the way how the data can be shifted serially bit by bit in one direction. This is what a serial in serial out function. Now the next is serial in parallel out. Now in this case the data is being applied in a serial manner. So input is serial while the output is parallel. So whatever data is being transferred serially here, the data is available in a parallel form simultaneously at the outputs of the flip-flop, that is QA, QB, QC and QD. So that way it will form a parallel word. So in this shift register, the data is converted from a serial data signal to a parallel data word. So you can see here the data is getting entered serially and it is getting available at the output parallelly simultaneously at all the 4 outputs of the flip-flop. Now the next is parallel in serial out. Now in this particular flip-flop, the data input is given parallelly to all the 4 flip-flops simultaneously. So the data is available or data is being applied or the input is given parallelly through the inputs PA, PB, PC and PD. and this data, once input parallelly, it can be taken out serially from one flip-flop to other flip-flop, that is QA, then QB, then QC and QD. In this manner, the data is available at the output, and that is in a serial fashion. So this is what a type of parallel in serial out shift register. As this type of shift register converts parallel data such as 8-bit data word into serial data, it can be used to multiplex many different input lines into a single serial data stream. Now the last is parallel in parallel out, that is PIPO. Now in this case, the data is being applied or the input is given in a parallel fashion. In the same manner, the output is also taken in a parallel way. So output is available at all the outputs of flip-flop, that is flip-flop A, B, C and D, at outputs QA, QB, QC and QD, while the input is applied at the inputs PA, PB, PC and PD. So this is the way how the parallel in parallel out shift register work. Now these are the, whatever we have seen up till now was the basic shift registers, the working of basic shift registers. But nowadays, due to high speed uh, versions of different electronic gadgets and all, we need to have a kind of device which is capable of doing all this or capable of performing all this task. And today such high speed bidirectional universal type shift registers are available, which may have a 4-bit multifunction, which may have 4-bit operation, and they can perform serial to serial, shift left, shift right, serial parallel and parallel serial and parallel parallel data transfer. So the name, hence it is given as universal shift registers. So universal shift register is a kind of circuit which is capable of giving all these basic operations which just now we have discussed. So this is what about the basic operation of one of the sequential circuit, that is nothing but a shift register. The further discussion regarding the other circuits we can do in the next class. Thank you.